Jason Christopher, who is one of the authors of this paper, was unable at the last minute to be here with us due to circumstances beyond his control. So I'm here doing this talk for him instead. My name is Fernsler, and I started working as a systems engineer at the Center of Supercomputing Applications at the University of Illinois. After 10 years in Illinois, I left to join the high-performance computing team at Lawrence Berkeley National Laboratory. In addition to managing HPC clusters at the lab, my team and I work with teams at the University of California, Berkeley to manage HPC clusters across their campus. This talk will highlight the work we have done to develop a more secure HPC cluster on the university campus and enable it to handle de-identified yet more sensitive data. Unfortunately, due to I already said that. This paper and presentation is about the approaches we took to bring our run-of-the-mill Beowulf-style high-performance cluster to a level to where it could handle sensitive data. Okay, so this is just a sort of brief description of our cluster at Berkeley and how it came into being. A number of faculty from across the campus at the University of California, Berkeley sent a letter in May of 2013 to the campus vice chancellor to state the urgent need for research computing support. Their timing was good as a new CIO and receptive vice chancellor funded the Berkeley Research Computing Program in January of 2014, and our first HPC cluster, Savio, went into production in May of 2014. Almost exactly 1 year from the date of the letter of the principal investigators. Well, we built it and they came. We have about 2,500 users on this system at this point, and there doesn't seem to be any indication that interest in signing up to use the Savio cluster is waning. The program is more than just HPC. Feedback on our original proposal indicated a need for comprehensive services. This is a multi-tenant environment with researchers from many departments over the campus sharing this resource. And this is an overview of the actual architecture or cluster itself. So we have about 500 compute nodes down here and 4 logger nodes. Our home directories are hosted over NFS, the NFS file system, as is the project storage. The Scratch file system is just 2 petabytes of on the Lustre file system. In addition to the Jupyter Hub node, we also have a visualization node and a data transfer node that is dedicated on the Science DMZ of ESNets. All the compute nodes and login nodes are connected by this FDR InfiniBand network, and everything is behind the firewall at this point except the data transfer node. Now, when we started this Savio cluster, our visualization node and our Jupyter Hub node were also outside the firewall, but as we discussed with our information security policy team, we decided that those 2 nodes, at least, the Viz and the Jupyter Hub, were things that needed to be behind the firewall. So this is an actual diagram of after we went through this process. So why are we doing this now? We had a lot of researchers come to us saying that they had a need for managing and handling sensitive data on a large scale cluster. They had small scale clusters, but they weren't able to use it computationally effectively, so they needed a bigger resource. So they came to us and they asked us. As with the original BRC program, researchers met with our Vice Chancellor of Research again and made a strong case for this more secure computing environment. They put a lot of pressure on them to provide support, a secure HPC system that houses their sensitive data to use as a large-scale computational resource for processing their data. Although the process included technical controls, it was largely policy-driven, and the entire process to complete it took from November 2018 to mid-March 2019. We had this existing BRC Savio cluster, so we decided to try to use that to leverage it into the secure system. We also thought that now would be the time to see if we can do that. Not just for general research, but one that could in parallel be used for researchers with more secure data. So what level of data are we actually talking about? The University of California, Berkeley has an information security policy team. And they had already set up policies and things for the smaller clusters these researchers had, so that we knew we could use them to help us come up with these guidelines for setting something up on the HPC cluster Savio. And there were a few levels of protection that the ISP team on campus defined. When we started Savio, you could say it was a protection level 0. That is, there was no special considerations for any sort of sensitive data that we took into account when we architected and built it. The highest level of security that the ISP team has defined is called PL2, which is closest to what it is the closest to what the Health Insurance Portability and Accountability Act standards would define. This is their level of that. But the data protection level that we were focusing on for our cluster was protection level 1, which is somewhere between 0 and 2. It's sensitive information intended for release. This is sensitive information intended for release on a need-to-know basis, but information that is not necessarily notice triggering. In other words, we do not have to report to any entity regarding the handling of this type of data. These are some examples of such information. You have employee ID numbers, you have data that falls under the level of protection defined by the Family Educational Rights and Privacy Act, such as student records and ID numbers, de-identified genotype and phenotype data, which come with unique protection requirements from the data provider that need to be carefully reviewed on a case-by-case basis. So our approach seems simple. We had researchers approach us with the sensitive data. Like I said, their cluster didn't just scale to their needs, so they really wanted to use Savio. But we did not want to pollute our current user base experience with a number of new security requirements. In fact, we didn't really want them to notice that much of anything in the environment had changed. We decided to use the information security policy team to make sure that all of the PL1 security requirements would be met. We had to successfully engage multiple IT groups on campus needed for this project, including the Campus Information Security Office, Campus IT, and individual researchers. The ISO is the most potentially challenging group because they had the power to halt the project completely. How did we do this then? We engaged our ISO by stepping them through the architecture of our HPC system, not jumping head first into security. By the end of the third meeting, it was clear the security team was intrigued. This fostered engagement and eventually co-ownership of the project and the challenges. In the course of the conversation, ISO told us that our HPC was the most complex architecture they had ever reviewed for compliance with their data security standard. We were all first pretty intimidated by the scope of this project, but found ourselves becoming more enthusiastic and optimistic of success the more we worked together. The end was quite satisfying. So here's an overview of the process. The ISP team came up with a minimum security standards for electronic information self-assessment plan. This was several weeks of meetings between the cluster team and the information security policy team, going back and forth on topics about what passes for secure access to the system for users, what passes for secure access to the system for administrators. For example, we can't log in directly as root anymore, even from another secure system. We have to log in as ourselves, go to whatever machine we need to act on as root, and then escalate there. They suggested that, and they asked, is the traffic back and forth between these several machines going to be encrypted? But there's no such thing as encrypted InfiniBand. There's no such thing as encrypted NFS. You can do block level encryption on drives, but there's no file level analogy. We were finally able to settle upon a process for encryption and deletion of data by researchers that would meet National Institute of Health requirements and satisfy our ASP team. Since the ISP team was accustomed to doing only single server assessments, we had to educate them about the basic HPC architecture of Sapio and the specifics of our environment so they could stop assuming it was a collection of just separate servers. They also expressed that our system was the most complicated system they had encountered to date. Finally, since the University of California, Berkeley does not have a medical school, the whole idea of having to secure sensitive data in an HPC environment was completely new to the researchers we had coming to us with this need. We needed to put policies in place to educate them about how to handle the data to ensure that the data could remain secured. So one of the first things we had to do was eliminate our dual home hosts. We had to secure our Jupyter Hub and visualization nodes behind a firewall, which is something we could have considered to begin with. We also had to instruct our prospective PL1 researchers not to use the Jupyter Hub or visualization host at all in any way with their secure data. The data transfer node, which is connected to the site EMZ, was not a candidate for being behind the firewall. So we needed to remediate that potential breach vector with a host-based firewall and additional intrusion detection system. By virtue of our HPC system being a multi-tenant environment, there was some question as to whether it must be considered a cloud computing environment as defined by the NIH. If considered cloud, then we would have to employ encryption at rest, or self-encrypting drives. Our ISO team supported close adherence to NHI rules for PL1. So how did we resolve this? We took a comprehensive approach, accepted the requirement for encryption at rest, and placed the burden of it on researchers as defined in our researcher use agreement, which I'll talk about in the next slide. They also wanted us to run the SysCAD Pro assessor. It's from the Center for Internet Security. You can find that online for details if you want. It runs about 230 individual tests on your system to assess it. And one of the first things I discovered it did, because it was taking forever to run, is that it basically tries to stat every file in every file system you have on the machine. So if you want to get it done within a reasonable amount of time, like say before next year, you have to unmount all your NFS file systems and your 2 terabytes of Lustre before you run this test. This is also to ensure that your storage admin does not kill you. We were not required to pass the score of 100%, which was great, because some of the recommendations for remediation we were unwilling to make. For example, not allowing root to log in directly to the compute nodes would make management of the system impossible. Also, it turns out, not allowing binaries to run out of /temp caused user Python builds to break, and disabling squash.fs broke certain container technologies altogether. So the reason why this is so important, that we had to come up with roles and responsibilities, is we were trying not to impact the experience of our existing user base by overdoing the technical controls, but instead implement process controls. The researchers, like I said, that we were dealing with did not have the experience of other researchers at schools that have medical colleges. So this idea of how to handle sensitive data was completely new to them. We needed to make them understand how to go about ensuring that the data they were dealing with would remain secured, so we developed roles and responsibilities for all parties in the process, including a memorandum of understanding. In the MOU, for example, researchers have to figure out what the data user agreements are and adhere to them. We expect the researchers to be responsible for knowing how and when they can share the data and when they have to delete it. We're essentially putting the responsibility on the researcher to make sure that they are adhering to the data use agreement. We put them through a series of training to familiarize them with the expectations of the general policy, the one set down by ISP. This way there is a shared responsibility between us and the researchers. We got a great partnership out of working out, this is the end result. We got a great partnership out of working out with the information security policy team. Originally, our management actually didn't understand how much work this would be and assumed that it would take us like 1 month, December, to put it all together, which gave the security policy team the impression that we just wanted them to certify Savio without having made any security changes to it at all. Needless to say, that first meeting did not go very well. But in subsequent meetings, we conveyed an understanding to both the security team and our management that we understood this would take months to accomplish. It was many, many weeks of intense meetings going back and forth with all parties involved to prove that a thorough understanding was achieved by all, and that all were comfortable signing off on the policy controls. I'm grateful to have been part of this process. It was truly an exciting and inspiring experience to be able to work with everyone to accomplish this goal, and we're all quite proud of it and look forward to working together on an even more secure system. So looking ahead, we currently have 2 groups of researchers in production on this secured Savio system, and that's only been 3 months since it's been in production, and we have at least 1 more waiting to garner access to it. Knowing that it took us 4 months to document a process of achieving secured compute environment to meet PL1 requirements, we can share this with other groups on campus attempting to achieve the same thing. It also puts us into a position to create an environment that is HIPAA compliant, a process that we would expect, given our current experience, will take about a year. Since the University of California does not have a medical school, and since the policy requirements for sensitive data under HIPAA are more stringent, we anticipate that it will take longer to familiarize researchers about the process of handling such data. This will almost certainly require more technical controls as well. Informal surveys indicate that many people handling such sensitive data have many levels of controls in place just to physically access the system housing the data, such as keeping it in a concrete bunker requiring at least 2 people with separate access keys to open as many doors, and a physical dongle required just to boot the systems. And I'm sorry this was a little short, but I was notified at the last minute that I should be doing this, so I'm done now. So if you have any questions, please let me know.